Okay, so we had the evidence of continental drift, seafloor spreading. We took all that and we've put it together recently. Upwards, up to about 50, 60 years ago, this theory didn't exist. Um, so it's a very young theory. But we took all that information and we've come up with this modern theory of plate tectonics. And plate tectonics simply says that the Earth's lithosphere, remember the lithosphere is the crust and the small upper portion of the mantle, are divided into chunks. Okay, it's broken up into pieces, and those pieces move around on the asthenosphere. All right. Page 5, we'll look at that in a second, has a lot of information on it, but it has all the plates on it. We're going to look at that in just a second. All right. So, what is the driving force behind plate tectonics? Well, it's convection currents down inside the asthenosphere. All right. So, under the ridge, under that ocean, that volcanic ocean ridge, we've got really hot material rising up from deep in the asthenosphere, where it's hotter, deep in the mantle. It's less dense, so it rises toward the surface, kind of pushes up on the ocean crust, creates that chain of volcanoes, and then as it moves apart, it starts to cool, becomes denser, and so it starts to sink. All right. This is why we have oceanic crust being so young. We've got new crust constantly being formed here, and then eventually, when it runs into other plates, it starts to sink back down into the mantle and gets remelted and recycled. So the Earth is kind of the ultimate recycling mechanism, right? Oceanic crust, very young, constantly being built and destroyed. Got a little animation here to show you kind of what I'm talking about. Up here, we've got a transform boundary. Okay, this is kind of the motion where two plates are moving apart from each other. Okay, over here, this is where they're moving toward each other. This is a convergent boundary. Okay? And you can actually see what's going on. This right here is called subduction. One heavier plate goes down underneath a lighter plate. Right? And then over here, this one you don't see much on this side, but if you look on this side over here, you can actually see, and this is what's going on underneath, but this is a top view. You can see new magma coming to the surface and solidifying, forming new crust, and then moving apart in a divergent boundary. Okay? All right, so here's, take a look at those three boundaries real quick. Transform boundary, they slide past each other, right? They're moving laterally. Good example of that I've already talked about is the San Andreas Fault. Okay, there's a few of them, and I'll point out a few when we get to that point. All right. Divergent boundary is when the plates are moving away from each other. All right. They separate, and when they separate, it allows magma to rise up and fill that crack, cools, solidifies, and forms brand new basaltic crust. And examples are Mid-Atlantic Ridge, East-Pacific, any of the ridges. Okay, any of the ridges are going to be places where the magma is rising up, making new crust, and it's moving apart. Okay. Convergent, moving away. Now we actually have three different types of convergent boundary. The first type is when an ocean plate meets a continental plate. All right. Oceanic plate is made of basalt. It's heavy density. Continental plate is made of granite. It's a lighter density, lower density. What happens is these two come together. This plate pulls down on this plate right here, and it creates a little trench that forms. And so we get a little trench that forms along off the coast, along the edge of that continental boundary, continental plate. Then, as it gets deeper, it starts to melt because it's hot, and it's now lighter, so it rises up. So we get a chain of volcanoes forming on the coast. Okay? A little trench off, and a little chain of volcanoes on. Okay? Some examples are the Andes Mountains and the Cascades, and I'll point those out in a few minutes here. Okay? Second type is an ocean-ocean convergent boundary. Two ocean plates coming together. Okay? The same thing kind of happens here. We've got a plate going underneath another plate, pulls down right here on this plate, and creates a trench at the bottom of the ocean there, and it also melts here, and the magma rises up, but then we get a chain of volcanic islands here. It's not over here on the continent anymore, okay? It pops up out here in the ocean. Some examples of that are the Aleutian Islands off Alaska, Indonesia, Philippines, Japan. These are all volcanic islands out in the ocean. And the third type is a continental-continental boundary, where you have two continental plates coming together, converging. Here, you don't really get a subduction going on. Okay, there's really no subduction going on. So instead of one plate sinking down, melting, and forming a volcanic range, here they kind of slam together and they both want to stay on top, so they crumple upward, creating a folded mountain range, not a volcanic mountain range. Folded. The layers get folded, twisted, warped. A lot of metamorphic rock is formed, that kind of thing. The Himalayas are a really big example of that, and again, I'll point out these things in just a second here. All right, so here's page 5. All right, down here, we have a key, shows relative motion, change colors here. Transform, they slide sideways. So an example of a transform would be right there. Transform boundaries. So we've got a big one here in San Andreas Fault. We got some down in here. Okay, and then there's tiny little ones that separate the ridges, but we don't need to worry about those too much. All right. Divergent boundaries are anywhere there's a double line. So double line, double line, double line, double line, double line. You get the idea, okay? Anywhere there's a double line, that's a divergent boundary, they're moving apart. Convergent is where you have a line with these little black boxes on it, okay? So let me get rid of some of this, it's getting a little crowded. Okay, so convergent is going to be here, and 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 here. You get the idea, okay? All right, now, the boxes are significant because they tell you which plate is going under which plate. So, for example, let's look right here, all right? The Nazca plate is on the side that doesn't have boxes. So if you look down here, the side that doesn't have boxes is your subducting plate. So this plate is going under this plate. This is what creates the Andes Mountains, okay? As the Nazca plate goes under this plate, we get this chain of volcanic mountains called the Andes forming all along the west coast of South America. All right. An example of an ocean-ocean boundary would be the Aleutians right here. We've got an ocean plate going this way, an ocean plate going that way. They're going toward each other. The Pacific plate doesn't have the boxes on it, so it's going under. So it creates these volcanic mountains, excuse me, volcanic islands out in the middle of the Pacific Ocean, North Pacific Ocean. That's called an island arc. All right. And then the continental, I told you the big one was the Himalayas right here. Okay? Still a convergent boundary. And at one point, India was down here at one point. So it's been moving forward. So there was subduction while this was an ocean plate. But once India ran into Asia, there's no subduction going on anymore because they're both continental plates. All right, so even though it shows subduction, there really isn't any going on anymore. But we do have the Himalayan mountains being created right here, a folded mountain range caused by India slamming northward into the Eurasian plate. Okay?